Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 25. Today, we're going to be talking about congruence shortcuts. Let's say as a building contractor, you've just received 2 triangle trusses to support the roof of a large building. You need to make sure that the triangles are identical. Do you have to measure all 6 parts, all 3 sides and 3 angles to ensure the triangles are congruent? We'll begin to look at congruent shortcuts by comparing 3 parts of each triangle. So there are 6 possibilities that the same 3 parts of 2 triangles may be congruent. These are diagrammed below. I want to point out that an angle that is included between 2 sides of a triangle is called the included angle. A side that is included between 2 angles of a triangle is called the included side. So our possibilities are the side, side, side. So if there are 3 pairs of congruent sides, are the triangles congruent? Side angle side, this would be a side and the included angle between another side. Angle side angle would be 2 angles and the included side. Side angle angle would be a side with 2 other angles, nothing included. Side side angle would also be 2 sides and an angle with nothing included. And the last possibility would be angle angle angle. 3 pairs of congruent angles. Will those always form congruent triangles? Today we'll look at 3, and in the next lesson we'll look at the other 3. So our first investigation would be the side, side, side. Is that a congruent shortcut? We're going to construct a triangle from the 3 given parts. Be sure you match up the endpoints labeled with the same letter. Try to construct the triangle matching endpoints a different way. Can you find another way to make a different triangle? So the easiest way would be to get patty paper and trace these, but if you would like to use a compass, you could also draw 3 different lines. And using a compass, you could draw a big angle to see where they intersect and if you could get more than one intersection. So here's my 3 lines. I'm going to connect them at the given points. And I use patty paper and I use 3 pieces so that I could easily move them. As I'm putting them together, there's one way that I can make a triangle out of these pieces. I'm going to try changing some angles, see if maybe I can rearrange, but I still have to get B to B and A to A and C to C. And there's just no other way that I can form a triangle and connect them in the exact same endpoints together. So that is my one triangle that I can make. So my conjecture is the side, side, side congruence conjecture. If the 3 sides of one triangle are congruent to the 3 sides of another triangle, then the triangles are congruent. So side, side, side is a congruent shortcut. Let's look at another one. How about a side angle side? Can we construct a triangle from these 3 given parts? Again, make sure you match up the endpoints with the same letter. We have a segment DE, a segment DF, and an angle D. Then try to match up the triangle a different way and see if you can make more than one triangle. If you can make more than one, then it's not a congruent shortcut because we couldn't guarantee that we would be making the same triangle every time. So with the given angle, I drew it so that you can have dots, it can go as long as possible. But then we're given DF and DE. So there's only one length on each of those that it could be, and only one way that you can form the angle. You have 2 points left, E and F, and that has to be connected with a straight line. So there's only one way that you can draw the DEF triangle. So our side angle side congruence conjecture, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Side angle side is a congruent shortcut. Our last one to look at is side side angle. Construct a triangle from the 3 given parts. Be sure you match up the endpoints labeled with the same letter. Try to construct the triangle still matching points a different way. Is there any other way to make the triangle? See if you can come up with more than one triangle from these parts. Again, if you can come up with more than one, it is not a congruence shortcut because we could be making different triangles. Here's our angle and two sides. I'm drawing my angle with dotted lines in case I can make the sides of the angle longer, the rays. But there's ST and it's set. However, I have TU. I can connect it right there. And if I rotate angle T, I can actually connect it in a second place. So I can form at least two triangles with these parts. If I can form more than one, then I can't guarantee that this is a congruent shortcut. So we don't have a conjecture for side-side angle. So again, reviewing, what shortcuts can we use from the ones we looked at today? Well, we looked at side, side, side. That was the first one, and we found that it was a congruent shortcut. So side, side, side. We then looked at side, angle, side. And that one also only formed one triangle. So again, that's the included angle between two sides. Remember, if the sides are set and the angle between them is set, there's no other way to draw the rest of that triangle except by connecting the two endpoints that are set and not moving. And the other one that we looked at was side, side, angle. And we found that there were at least two possibilities, so that is not a congruent shortcut that we can use. Come back for the next lesson to see what else we can do.